Welcome to video 8b.3, which is about solving rational equations. And actually, this is something that I made a video for back in chapter 1, section 6, or video 1.6. So if you'd want more examples than just these three, feel free to look back at that for reference. And in fact, I'm going to be doing these problems a faster way because I think at this stage of your academic career, I want you to do it the fastest way possible. But if you want to go back and look at the section 1.6 video, that does show a longer way with more steps if you would like to use that as a resource. So if I want to solve fractional equations or rational equations, there's two things I want to look at the beginning. First, what is the least common denominator? So if we looked at the original equation, we have a denominator of 1, x plus 2, and x plus 1. So that means that each denominator needs an x plus 1, and each denominator needs an x plus 2. Yes, it also needs a 1, but multiplying by 1 does not make a difference. So what we've done in the past is multiply the entire equation by this greatest common denominator, and I will do that in just a minute. Something else you need to keep in mind is that from the beginning, because this is a fraction, we cannot divide by 0, which means that x plus 1 cannot equal 0, and x plus 2 cannot equal 0. So two numbers that are not possible is -1 and -2. So if you get either of these answers at the end of the problem, they're extraneous and won't work. But anyway, let's get down to the actual solving of this. If I looked back at the original equation here, then what I would do first is multiply the entire thing by the common denominator, which is x plus 1 and x plus 2. So think about what each fraction needs. So this first one has the x plus 1. And so what this 4 is going to need to get the whole common denominator is the x plus 2. So we'd have 4 times x plus 2 minus 3. Now this fraction has the x plus 2, so it's going to need the x plus 1 equals 1. This does not have either of the common denominator pieces, so it's going to need both x plus 1 and x plus 2. Now some of you might be wondering where the denominators go. Well, the reason we multiply by the common denominator is if you think about it, and if we actually distributed this denominator to each one, you would end up getting each of these pieces, because this x plus 1 would cancel with this x plus 1. This x plus 2 would cancel with this x plus 2. So here you'd only be left with the x plus 1, here you'd only be left with the x plus 2, and here you'd be left with both because nothing could cancel on the bottom. And so because it's an equation, you can legally multiply by the common denominator and cross things out. Or you could think of it as I said it and what each piece needs. Now that we have this equation, because all the parts we needed crossed out, we could distribute. So you'd have 4x plus 8 minus, and make sure to distribute the negative to both, 3x minus 3 equals this lovely thing. Now the 1 technically isn't there, so we're going to have to FOIL these two parentheses. Get x squared plus 2x plus 1x plus 2. If we simplify both sides, we would get x plus 5 on this side equals x squared plus 3x plus 2 on this side. If we got one side equals 0, we'd have x squared plus 2x minus 3 equals 0. If I factored this, we'd have x plus 3, x minus 1. So my two answers are -3 and +1. And if I check that with the two original things I cannot have as answers, neither of them apply here. So my answers are -3 and +1. If we look at example number 2, it looks like my least common denominator is going to be, well, here's the denominator is 1 again. So technically a 1. Each fraction would need an x, and each fraction would need an x minus 1. Now, before we multiply everything, I would suggest moving the 1 over to the other side. So 1 over x minus 4 times x minus 1 equals 1. So just like last time, if we multiplied the entire equation by the least common denominator, x times x minus 1, we could technically distribute this to every term and ask ourselves what each piece needs. Before I'm going to do that, though, let me make sure that I write down that x cannot be 0 and x also cannot be 1 in order for the denominators not to be 0. So if I continue and I think about distributing this, or what each needs, this first fraction has the denominator of x, so the top needs the x minus 1. So this would become 1 times x minus 1 minus 4. This has the x minus 1, it needs the x. So minus 4x equals 1. Just like last time, this is going to need both pieces, so it's going to need the x and the x minus 1. So if I simplify this, we would have x minus 1 minus 4x equals x squared minus x. Again, just like last time, if I get everything to the other side, well, let me simplify first. Negative 3x minus 1 equals x squared minus x. 0 equals x squared plus 2x plus 1. If I factor, I will get x plus 1, x plus 1. So I get x equals negative 1. And x equals negative 1 passes the test. It is not 0 or 1, so this is the only solution, x equals negative 1. The last example, I want you to notice a couple things. One, that this is really 3 over 1. Also, that this denominator can be factored. So if I do that first, two numbers that multiply to be negative 6 and combine to be negative 1 would be x minus 3, x plus 2. And that would be equal to everything that you see. So I'm going to let you try this one on your own soon, but first, let me just throw your way that the least common denominator would again be 1. You would need an x minus 3, because both of these have it, and an x plus 2. So your common denominator would be x minus 3 and x plus 2. And so what I want you to think about is what numbers cannot exist in the problem. I want you to multiply the entire thing by the greatest common or the least common denominator. Think about what each fraction needs. So please get ahead of me. Try as much as you can. And when you come back, again, I will have the work. Thank you. Please pause now. Just a quick check-in with you. When I distributed this LCD to here, I noticed that both of these would cancel because this doesn't need anything. So I was left with just x plus 2. When I distributed to the 3, I noticed that this fraction needed both these pieces. So I had 3 times these two binomials. Then when I distributed the LCD to this term, it had the x minus 3. So the negative 4 needs the x plus 2. So I just wanted to check in with you that you had this in purple. As a hint to you before I pause again and keep going, I would suggest foiling these two and then multiplying that answer by 3. And please don't forget that you're distributing a negative 4. Okay, let me pause again, keep going, and I'll come back with you. All right, guys, so to check back in with you on this lovely last problem. First, if you got to a point where you had to split the middle term, great job. I foiled this and got x squared minus 1x minus 6 multiplied by 3, made sure to distribute the negative. So if I scroll down a little bit, you can see that my final quadratic that I had to factor was 3x squared minus 8x minus 28. If you did not get that, I would pause the video and check with my work. At this stage, I did end up splitting the middle term. A times c was negative 84. The pair of numbers I used to split was positive 6 and negative 14. I found the greatest common factors of both pieces, and I ended up factoring it to 3x minus 14 and x plus 2, which meant my two possible answers were 14/3 and negative 2. Unfortunately, when you looked back at the original problem, because the denominators were x minus 3 and x plus 2, 3 couldn't work, nor could negative 2. So when I went back and checked my work, we got an answer of negative 2, so this was extraneous. So the only answer that worked was 14/3. All right, guys, thank you for joining me for the rational equations video. I hope this way was a quicker way than before. Best of luck practicing it cumulatively tomorrow with other types of problems. And again, thanks for joining me. I'll see you next time.